class. In this video, we are going to talk about our second problem in homework 8, the whole problem. So I'll first briefly talk about the background of the problem and then how to solve the problem with the risk, and then we discuss some of the results. Firstly, if you remember, this is a short haul problem, which means you are trying to handle the overflow job from UPS and FedEx. So every night you get a job from these big carriers, and this is the historical data that they give you the jobs. So sometimes you get line, some day you get 3, sometimes you have 0. So there are some randomness in the number of jobs you could do every night. And the revenue you get for each job is following this distribution which is described here. For each job, the minimum revenue you can make is 300. The maximum revenue is 1,300, and most likely you would make $1,100 for each trip you made. So that's a triangle distribution. And in order to do job, to do a delivery, you have to hire a driver and a truck. And the total cost is $3,075. That's your cost to hire a driver and truck combo, which is the sum of 200 and 175. And the number of drivers you hire is your decision variable. So you want to decide how many drivers you hire. So that's basically the problem. So let's look at how to solve this problem. So the first thing we need to do is to use the historical data to predict your random demand. To do that, we have to use the risk function called distribution fitting. So let's first load the risk add in into our Excel. Okay. So we're going to use distribution fitting. So we talk about in class. Basically, is to generate a distribution function that fit our historical data. So it seems there is an existing distribution property I generate. So we're going to new distribution. So we're going to choose the range of data. It seems the default choice is quite good. So we're going to continue with fit. And it's going to fit this data with Weibull distribution. The first one is Weibull. Probably don't know what Weibull distribution it is. Let's just take it is. And we're going to use this distribution to generate random demand. So we're going to write to a cell. Let's click next. So this is the function you're going to write. Right, next, and you're going to tell the program which cell you're going to write your forecast. So we're going to write into C4 in this worksheet which will correspond to number of jobs you would do every night. So so you can press F9 to see different realization of the random variable. It seems it doesn't change because we didn't change the setting here. It's static value. That means you would always return the mean value, and you have to check the random value. So that means it will show you a random value every time you hit F9. But we don't like these decimals because the number of jobs is integer. So we can add a rounding to this number here, round to 0 decimal. So now we get an integer. So these are the number of jobs you could have every night. Next, we're going to generate another random variable which represents the revenue you can earn for each job, which follows the triangle distribution. So that's to define a triangle distribution. Triangle to represent the number, the revenue for each trip. The triangle has 3 parameters. First is your mean revenue. In this case, it's F4. And the next set of value is the most likely, which is G4, and the next one is the maximum, it's H4. This is the maximum value. So this gives you a preview of your distribution. It's a triangle. You can press OK. So in this case, in this scenario, you have 3 number of jobs, and the revenue you can earn is for each job is this amount. However, you can't always do 5 because it's also constrained by how many drivers you have. Suppose you hire 3 drivers that just have any value 3, and the number of job you can deliver is basically how much job you get from UPS and FedEx and how many drivers you have. So that's the total number of job you can deliver. So in this case, in this scenario, you only 1 job, so the number of job is delivered is 1. So in this case, you have 30 jobs, but you only have 3 drivers, so number of job delivered is 3. So every time you hit F9, you can see different realization. Total revenue will be the number of jobs delivered multiplied the revenue per job. And then the cost is just the number of driver you hire multiplied by cost handle. The profit is your revenue minus the cost. And we're going to track the profit, so we're going to define profit as an output, so add output here. Now we actually be ready to start to run a simulation. For example, I can start simulation here, set simulation number to 1, start simulation. What it would do is to evaluate the total profit for a given decision variable, meaning number of drivers you hire is 3. So this is the profit. This is a histogram here, and you can also see the mean profit is this amount, the standard deviation of profit is this amount. Okay. But what we actually interested is to look at for different number of drivers I hire, what's the profit, how the profit would change. So let's just first write down what the possible number of drivers I can have. Say I can have 2, 3, 4, 5, 6. These are the possible number of drivers I probably hire. And in order to let the program evaluate these values, I have to change these 3 to risk semi-table. Use this risk semi-table function and tell these are the number I'm going to evaluate for the simulation. Since we have 5 different values to evaluate, we're going to change the simulation to 5. And then we can start the simulation. As you see here, is running the simulation for 5 different times. The first one corresponding to the number of driver of 2, the second one corresponding to the number of drivers 3. So we can look at the simulation result for different simulation numbers. And it has the mean profit and standard deviation, the maximum and the minimum profit. And to get another way to look at a result is click summary here. So you can directly see the profit for even simulation numbers. Especially we want to look at the mean of the profit, which says the average profit. So in this case, as you see here, the simulation 3 has the largest mean profit. That means the simulation 3, which corresponds to number of driver 4, will maximize our profit. Another way to look at the result is to report the result into Excel, export the result to Excel. So we can click Excel report, and we can click output result summary, where you can check different output report. But we are going to look at output result summary here. Press OK. You will have this in a lab, this windows. That takes a moment. It seems it's coming. Since I'm working on my personal computer, so this might be a little bit slower, you can get a free trial version on at risk. by just Google the risk free trial version. It seems my computer is dead. Let's wait for a few seconds. But you get an idea. What I'm trying to do is to look at the result in Excel so that I can copy those profits here, and so I can make a clear comparison of different alternative number of drivers. But as I said before, in this case, if we hire four drivers, we would actually maximize our expected profit. And that should be sufficient to answer this homework question. Let me see. Let me see if I can close this. Don't save. See, okay. Seems I have it seems I have a conflict, so I'll just close the other Excel worksheet. Let's try again. Press OK. We should be able to see the result. Yes. So this is just what we have seen originally. It says for different simulation numbers, for each simulation, what's the mean profit, what's the average profit, and what's the maximum profit. We want to look at the mean, which says the average profit we earn for that corresponding number of drivers. So we type profit here, and we can use a conditional format to highlight the one that gives us the maximum profit. So that's as you see here, if our number of drivers is 4, we can maximize our profit. If we want to look at the risk associated with each decision variable, we can look at the standard deviation of the profit, which we can easily do by browse the result. Say we want to look at the standard deviation for simulation number 1. So we can see simulation number 1, standard deviation is described here on the right panel here. Standard deviation is 859, and for simulation number 2, the standard deviation is about 1000, which is quite big. That means we have a lot of variation in our profit. And next one, simulation 3, standard deviation is 1378. The next one, standard deviation is 1713. The next one is 2003. 7. So as you see here, there's a lot of variation in our profit as we increase our number of drivers. The reason, as I said, is when you hire additional drivers, then sometimes if you don't get enough demand, they are basically idle, and you have to still pay the cost. That brings a lot of variation to your profit, and also increase your risk of your investment. But for the sake of this homework question, we should be safe just to choose the number of driver being 4 to maximize our expected profit. That should be sufficient. Thanks for watching. That's all for this homework question.